Let's just do a quick survey before we start. Is anyone here working with reactive streaming apps of any kind? It's a fair bit of hands. Anyone using Akka Streams by all chance? Any other tool? Sort of Monix or Monix? Okay, that sounds very good. It's definitely more than I was expecting. So, regardless of the tooling that you use, the streaming apps are definitely becoming more and more part of our lives, especially if you're a back-end dev, because we're ingesting more and more data and we need to process it as soon as it's captured, right? So, it's just like any other app, streaming apps need to be monitored, right? So we can all agree, hopefully, on that. So this talk will try and tackle a few challenges that apply to monitoring reactive streaming application and try and answer some questions around these challenges. So we'll see some practical examples with Akka Streams, but in general, some of the consideration should apply to all kind of streaming apps. So that's me. You might wonder why there's my picture. I'm here in the flesh, but yeah, that's a good point. So I work for HomeAway as an engineer. HomeAway is a company that's part of Expedia Group, and essentially we're a big vacation rental marketplace. So I encourage you to take a look at homeaway.com. I see some nice villas there, some nice places to stay. At HomeAway, we've always, well, for a long time at least, we've employed reactive streaming and event sourcing, and we just wanted to let you know how we tackle the issue of monitoring these things. So I'm assuming, again, you're all familiar with why we're monitoring stuff. Essentially, we want to track and observe what's going on in our systems to be the first to know in case something goes wrong, or if something goes particularly well, but usually we're interested in the wrong part, right? So first to know is one of the HomeAway tech principles as well. So we really care about trying to operate a business that's self-monitoring from the get-go, and that's a bit of a fancy lingo to say that we want to think about monitoring while we go along, while we develop the system, and not just like a nice cherry on top when the system is all loaded. So monitoring, of course, is powered by metrics. As you know, like these are like raw measurements that you get from your system, and you observe and collect them throughout time. So metrics, there's like all sorts of metrics. You can think about business metrics, metrics for your CI/CD pipeline, more low-level system metrics, performance. But when it comes to reactive streams, there's two key metrics that you need to understand. To kind of get a grip on like how your app is doing. And these are the two that we're going to talk about. So we want to keep an eye on how many things or data item or requests are going through our pipeline and being processed, and this is throughput. And we want to know where our bottlenecks are. And that means in a reactive streaming app, we want to know if and where our pipeline is backpressuring. So this is the second bit we'll take a look at. So you can think of many more metrics you can collect when doing reactive streaming, but these two are going to give you a pretty good understanding of what's going on in your stream. So we're gonna see these two, why they're relevant, and what challenges they pose. So we're going to start with throughput. Why do we measure throughput? So in a traditional web service that we all know, we usually think of throughput as, you know, amount of requests served per unit of time. So usually we have some SLA around that. We probably want to meet some kind of load, incoming load on our service. And this is true also for streaming apps, of course. So this kind of need doesn't change. However, when we're dealing with streaming apps, it's some of the assumption that we make when dealing with traditional web service, they're not there anymore. And there's two main challenges there. And there are two sort of non-linearities, if you allow me the term. So one concerns topology. So this is a web service. Requests come in, responses come out. However, in a streaming app, you have a variety of publishers, subscribers, and things that go on. You can fan in, fan out. Basically, your topology becomes much more complex, right? So this is one thing that adds complexity. Secondly, in a traditional web service, you've got, again, one request coming in, and you expect one response coming out. if the service is healthy and it's not hanging and assuming everything goes well. So in a streaming app, you don't necessarily have this linear correlation between inputs and outputs. So in a reactive streaming processor or in a flow, if you speak Akka Streams, you can have one input and the processor might give you from 0 to infinite outputs. And the processor could even start sending outputs even if no input is presented. So as you can see, the relationship is much more generic, and this adds complexity as well. So you can even think about a web service as a specific version of a streaming app where we have only like basically an incoming stream of requests and an outgoing stream of response. This is actually how it's modeled in Akka HTTP as well, if you're familiar with it. So does it make sense to talk about throughput for a whole streaming app? Not really, right? In a general sense. We want to know the throughput at different points. So we want to monitor specific points in our graph, in our stream, and check the throughput there. So one simple way to solve this is to basically instrument our stream with different transparent processors or checkpoints. And these are basically sections of your pipeline where you take the input, you just present it to the output as in the same form, and you record metrics as a side effect, right? So this is a very simple approach. The main idea is to create these reusable checkpoint components that you can place wherever you want, wherever is meaningful for you. Of course, you can go crazy and put it wherever you want, all over the graph, but maybe some points make more sense than others. This is sort of up to the developer to decide, right? So let's see how this translates into code. This is a very simple Akka Streams example. So we have a source, a flow, and a sink. The source is a source of strings. We have a flow that explodes the string. This is what map_concat does, if you're not familiar with the DSL here. Essentially takes every incoming string and it explodes it into characters and emit all the characters one by one downstream, right? And then we have just a sink that prints. So this is a very, very simple, trivial example, but it's already an example where you have different throughputs at different points of your pipeline, right? Before the map_concat and after the map_concat. So then, you can just concatenate these things using Akka Streams DSL and run the pipeline. This will just start pumping over the strings through the pipeline, right? So we can define something like this, like a meter to measure the throughput. This is a very, very trivial implementation. This is what I meant when I told when I said transparent processor. This is basically a flow that takes whatever comes in input and presents it in output, but also creates a counter. In this case, it's a common counter, but you can use whatever metric backend you want in a place like this, and increment it for every passing element, right? And then the element is presented at the other end of the map, right? So essentially now we can place these meter wherever we want. Again, because we're interested in seeing maybe the variation of the throughput here, we could place a meter before the processing logic and a meter after, right? And then we can use like labels to make some sense out of these measurements on the back end. So this is very simple. We see now how we can measure throughput. It's quick and simple, and we're happy with it. Let's move on to back pressure. Why do we want to measure back pressure? So let's explain this with a simple example. So let's say we have a pipeline like this, right? So we have a Kafka log, we read from it, perform some kind of validation, some things are marked. This is invalid, they go to a log file. Some things are marked as valid, they go to some HTTP API somewhere, they get stored, and then as a last step we commit to the Kafka cluster or offset, because we're fine with our processing. So let's say we instrument this graph with a throughput meter that we just saw, and we get back some nice numbers. So let's say the number come back like this. We read from Kafka 100 messages a second. Roughly a quarter of these are invalid. 3/4 go through, and then they're stored, and right. So there's two possibilities now. either we're happy with these numbers and we can all go home, or we're not, right? Maybe the SLAs here are not met. What if, for example, we have a Kafka topic that produces way more than this, and in the thousands of messages, and we have our log that goes on, and we want to be able to do more than this, right? One option could be like we just parallelize this thing, we just deploy 200 of these things over on AWS, spend all our budget, which is not ideal, or we try and work out some optimization for this guy, right? So as you can see, we need to find our bottleneck. So the throughput reading there are not really, they're a bit useless, right, if you want to find a bottleneck in here, because they all align to the slowest component of the whole pipeline, right? Is it clear where the bottleneck is? Maybe it's the storing API, maybe it's the commit to the Kafka cluster that is particularly slow. We don't know, so we need to do something more. And the reason why these measurements are all aligned to the slowest kind of ring of the chain is because of back pressure, right? So let's just see what back pressure is. So back pressure is a very desirable feature of your system. You don't want to overflow your pipeline, just like in this case. You want to overflow your pipeline with messages that you can't process, right? And this makes your system resilient by design. So it's a very important property you don't want to lose. And it's crucial when dealing with unpredictable volumes of data, or fish. So let's stop for a sec and recap how Reactive Stream works, just for 30 seconds here. The key thought is that it's this guy, it's the subscriber, or a sink, or a consumer, or whatever you want to call it. It's this guy that signals request for elements. Okay, now I'm able to request to process something. Please send me more, right? And this gets propagated upstream until a publisher is able to emit something. That's then again propagated downstream. So this is how Reactive Streams work, and this is how we preserve the safety of the whole pipeline, just by consuming whatever we can process. So essentially, our pipeline is back pressuring when we are waiting for a request to come from the downstream. I'm talking about the pipeline back pressure at this specific point here, when we wait for a request from the subscriber. This means that the subscriber is busy, basically, and it cannot do much. Conversely, when a request has been made and we wait for the element to be sent to us, in this case, the element to be emitted to us, this is when the pipeline is not back pressuring, right? So we've requested something, we just want it. So we are in the opposite state of non-back pressure, however you want to call it. So how can we measure this back pressure? What if we could somehow measure the time that that we spend between requesting an element and emitting it, and vice versa, the time spent after an element has been emitted and the following request has been sent. So a ratio of these two will give us basically the relative amount of back pressuring that goes on in our pipeline in this specific point, and then we're going to need to measure it somewhere else as well. So as Reactive Stream in general, they prescribe the synchrony, and it's a very general spec. It might not be a trivial problem to solve, discerning time between these two signals here. So it might be quite tricky. Thankfully, Akka Streams makes our lives easier here by basically sequentializing some of these events in the same context. We'll see what we mean by that. So we'll take a look at how we get this done in Akka Streams. So this is the graph stage API. It's the lowest level API that's there in Akka Streams. I'm sure some of you have seen it. So every stage in Akka Streams is implemented using this, and essentially provides a way to create a streaming stage by defining handlers on its input and output ports, right? So for output ports, we can define a handler called onPull, and for input ports, we can define a handler called onPush, right? So this is essentially how every stage in Akka Streams is defined underneath. So for example, just to give you an idea don't get distracted by the pizza. To give you an idea, this is how map works in Akka Streams. So this is flow.map that you've all seen. Essentially, it uses GraphStage API. It has two ports, in and out. They're typed. We have a logic with two handlers, on push and on pull, on both of these ports, right? So when upstream pushes, we basically grab the element from the input port, we apply the function that we use to build the map, and we push the result downstream through the out port, right? So when the downstream pulls, conversely, essentially we just propagate the pull upstream, asking for a new element, right? This is because map is a simple stage. It just says, whatever's upstream, just please give me what you got. So this is the API that Akka Streams provides. How can we leverage to make these measurements for back pressure? So the most important thing to keep in mind here is that graph stage is never accessed concurrently. So it's basically similar to an actor if you work with those. It gives you essentially a sequentialized context, and you can rely basically on the Akka Streams infrastructure calling these handlers in a strict on-pull, on-push sort of dance, right? So this makes things easier for us. Basically, you can create a graph stage that measures this back pressure ratio for us in this way. This is a simplified approach, but it still does the job. So we can have two vars, one we call last pull and one we call last push. And we can use vars inside the stage. Again, as you would use vars inside an actor, is one of the few places where you're actually fine to use these things, and you don't need to be scared of. This is because Akka Streams does a lot of things for us. So these are going to be our state. Then we can have, again, our matrix backend, and again, this is a common histogram, but you can use whatever you want. And this is going to store our readings. So now down to the handler. So when a pull comes in, essentially, first thing we do, we propagate the pull like we do with map, right? But also we also set our last pull variable as of now using system nanotime, right? So when a push comes in, conversely, we again push out the same element. We don't have any function to apply now because this is a transparent flow. And now we can do this calculation of the ratio between the time spent waiting for the pull and the time spent waiting for the push. So this specific implementation will give you a percentage where 0% means the pipeline is never back pressuring in the last cycle, and 100% is when the pipeline is always back pressuring. Most likely it will be something in between, right? So this stage can be used in the same sort of fashion that we saw with the throughput meter before. We can place wherever you want in your graph to get a reading on your back pressure. So just to sum up, essentially we have discussed an approach to monitor Akka Streams, but some of the considerations are basically valid for any streaming application. You need to make sure you monitor your pipeline at different stages in crucial points, and you have to get a good understanding of how both data and back pressure propagate, because it's with Reactive Streams it's always a two-way communication there. You have to, measuring throughput is not enough, you have to see how back pressure is propagated as well. Otherwise you will have basically a very opaque stream. You just start it and you don't really understand what's going on inside, and it's very tricky to understand bottlenecks. Yes, sorry.
Can I ask a question? So I use Camel at work, and it comes with a bunch of really good modules.
Yeah.
Is there a module for streaming or anything particular like that? And I've got another question as well. I'll ask you that afterwards too.
Yeah, I appreciate that. Thanks. One at a time. No, it's a good question, because there is a module for Akka in Camon.
Yeah.
There's not a specific module for Akka Streams that I know of.
Yeah.
And one might argue you might like shoehorn the Akka Camon module to make some sense out of your Akka Streams, but it's not. I mean, it's very generic, and what Akka Streams does with actors underneath is not exactly something you want to be exposed to. It's not something that you care too much about.
That's good.
So you might get some insight out of that, but the problem is with these like general purpose sort of frameworks that you might use, that they're just too generic. You wanna instrument your graph yourself, because only you know where readings matter, and then you wanna display them out in a very, very kind of visual way, maybe using Stefano or whatever, to make sure that you know where things go wrong in your graph. It's very tricky to get done, I think, on a generic sort of framework.
I mean, the other question I had is does Akka Streams taste better than the pizza?
Sorry?
Because my mind is on the pizza.
Okay. I don't think it does.
Okay.
Sorry. But yeah, just have to try for yourself both and then see. Just 1 minute to close though. These things are all on GitHub. Just put it out as a tiny micro library. It does give you a checkpoint flow. It does give you throughput, back pressure, a few other things. But it's very much work in progress. So if you work with Akka Streams and you want to give it a go, I would very much look for feedback there. There's a microsite as well, some docs. It works for both Common and Drop Wizard backends. They're sort of pluggable backends. And it's currently on Maven Central as well. So in the sort of demo section of the GitHub repo, you'll find a way of easily kind of get like a viewable way, a visible way to visualize your metrics here via some very crude Grafana boards. So yeah, I encourage you by all means take a look. And yeah, I'm done. Pizza time. Yeah, thank you very much.